All right, we're on 2.15. We are almost done with cycle 2B, and then we'll start getting ready for that cumulative exam. That's at the end of cycle 2B. So remember, there's not a summative, it's a cumulative exam at the end of this cycle unit. Okay, so Pythagorean Theorem. I'm sure you've seen this before, you've heard it before, you've used it before, so this shouldn't be anything new, earth-shattering, or hopefully it's not difficult. So for this first one, for each rectangle shown here, draw a diagonal and estimate its length as accurately as you can, estimate being that key word, and then assume each segment on the grid is 1 unit. Describe any relationship you see between the sides, the lengths of the sides, and the length of its diagonal. So for this one, very simple. I'm going to count the units. So 1, 2, 3, 4, 5, 1, 2, 3. I'll draw in my diagonal and I'll kind of estimate how many squares I see. Yes, when I make my diagonal, it's not totally 6, but I just counted like each square box that I went through as maybe 1 square. Is it accurate? No, they just told me to estimate, so that's what I did. That's how I estimated it. Next one, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Draw in my diagonal, and again, I just kind of counted the squares that I went through as a whole box. So for that one is 8. Again, 6 units, 4 units. I drew a line and I said like 8. I put a question mark there because remember, it's an estimate. It's not totally accurate. You could have also done that like little squiggly line for about 8 units, but I just like the question mark. Okay, and then the last one, 9 units, 6 units, and 12 units. Describe any relationship that you see. Well, the length of the diagonal is going to be longer than the length of either side. So we have that. That's probably pretty good. Okay, then lots of reading. Pythagorean Theorem. Leg squared plus leg squared equals the hypotenuse squared. A squared plus B squared equals C squared. Hopefully that's not new to you. Go ahead and read through all of these notes if you want to. They have example problems done, worked through. Take each leg, square it, add them together, and that equals the diagonal squared. Okay. Another example, they broke it down even more and explained each step in case you're really confused. Example number 2, find the length of the hypotenuse of a right triangle if the legs each measure 10 feet. Okay, so each leg, so I'll go 10 squared plus 10 squared equals the hypotenuse. I don't know what the hypotenuse is, so that's C squared. And remember, this A squared plus B squared equals C squared only works for right triangles. So if it's not a right triangle, I can't use this this formula, this theorem. It's not going to work out. And then all I'm doing is solving for C here. So I square the 10s. 10 squared is 100. 100 plus 100 is 200 equals C squared. Now I'm solving for C. So to get C by itself, hopefully you know that I take the square root of each side. And that should actually say 200, not 100. I'm not going to actually take the square root of 200. I'm just going to leave it like that. I think that's fine. If you want to go a step further and actually square root it out, it's just go on Desmos, square root of 200. So each side length is, or your hypotenuse is going to be 14.14 feet long. Okay, next one, find the length of the legs of a right triangle if the legs are the same length and the hypotenuse measures 10 feet. Okay, so again, each of the legs are the same length and the hypotenuse is 10 feet. So we have 10 feet, A squared plus A squared. Why didn't I do A squared plus B squared? Well, A represents one number and B represents a different number. If they're both the same length, I can use the same variable. So a squared plus a squared. If I had an a squared plus a b squared, I wouldn't be able to solve it. It wouldn't work out and I'd get confused. So a squared plus a squared. Then I'm going to combine like terms. So 10 equals 2a squared. And now I can divide both sides by 2. So I'm left with 5 equals a squared. And then from there, I didn't make a mistake. And it's the square root of 5 equals a. So both sides are approximately square root of 5 units long. Again, if you wanted to be specific, square root of 5 is 2.24 feet long. Okay. Pythagorean triples are just 3 whole numbers that satisfy the Pythagorean theorem. Not decimals. They're nice whole numbers, which I always like whole numbers. I hate decimals. And when you have a triple and it's written out, like a 3, 4, 5 is the most common one, the last number is going to be the length of the hypotenuse. So 3, 4, we use the Pythagorean theorem Pythagorean theorem to complete each of the triples. We've got 3, 4, the next one is 5. I just wrote that one in because that one was kind of given. You're using the Pythagorean theorem if you don't know these. So 6, 8. So 6 squared plus 8 squared equals what? 10. And then you've got 9 squared plus 12 squared equals c squared. If you solve, you get 15. Some of these are kind of, you'll notice that they're a reduction or an inflation of another one. So 30, 40. Well, I had 3, 4, 5. So 30, 40. The next one is going to be 50. Next one, 57 squared plus 76 squared equals what squared? It's going to be 95. And then 60, 80. Well, I had a 6, 8, 10. So it'll be 100. What relationship do you see between the first and second Pythagorean triples, between the first and the third? They're all proportional. If you reduce, it's still a 3, 4, 5 right triangle. So for the first and second one, 3 to 6 is times 2, 4 to 8 is times 2, 5 to 10 is times 2. So this one was just double the size. And then this 9, 12, 15, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. This one is triple the size of the original triangle. So they're all proportional. For number 4, notice that if A, B, C in a Pythagorean triple, if A, B, C is a Pythagorean triple, then so is every multiple of A, B, C that results in whole numbers. So just like I had 3, 4, 5, well, a multiple of that, so 30, 40, 50 is also 1. I just multiplied it by 10. I could multiply by 11 or 12 or 13, and it's still going to be a triple so long as it results in a whole number. Number 4, if a 5, 12, 13 is a Pythagorean triple, name 2 more triples that relate to it. So I can just multiply by any whole number that gives me another whole number, and it'll be a triple as well. So I could multiply by 2, so 10, 24, 26, or another easy one, I could multiply by 10. Or I'm sorry, I actually multiplied by 20 for the next one. I could multiply by 10. So I could have 50, 120, 130. I could multiply by 20 and get 100, 240, and 260. Again, complete the following Pythagorean triples. 8 squared plus 15 squared equals what squared? It's 17. 14 squared plus 48 squared equals what squared? 50. Are you supposed to memorize these? No, absolutely not. The only one that I know off the top of my head is 3, 4, 5. If I wanted to know another one, I would just Google it. So if you wanted to Google those, you totally can. There's really no way for me to know and catch you if you do that. Okay, so when would we use Pythagorean theorem, Pythagorean triples? Here's a real life example. Home builders trying to square the corners of a property. A string is measured 7 inches from a corner on one side and 2 feet out on the other side. So they drew a diagram to help them out, solved a Pythagorean theorem. Okay, so read through that one if you want to. And then the last one we'll do, Jack has instructions for building a skateboard ramp, and he needs to build a triangular frame on which to nail the ramp board. So he'll use a 4-foot by 8-foot piece of plywood to serve as his ramp. Jack wants the plywood oriented so that the ramp is as long as possible. The instructions say to choose the desired height for the ramp, and then use the Pythagorean theorem to find the length of the frame that will sit on the ground. He wants the end of the ramp to be 2 feet off the ground. So draw a picture to get started. I think drawing pictures is great because this was a lot of information going on. So definitely he wants the ramp to be 2 feet off the ground. So I'm going to first draw my triangle, and I drew it 2 feet off the ground. It's 2 feet high. And then why did I put 8 here as the hypotenuse? Well, we definitely were being asked to find the length of the frame. So I definitely don't know this bottom piece. The only other piece of information that I was giving is that I'm using a 4-foot by 8-foot piece of plywood. So I really want my skateboard ramp is going to be, I'm not good at drawing 3-dimensional pictures, so this is just 2D. I've got a 4-foot wide piece of plywood by 8 feet long. So I want to use the full 8-foot length of that piece of plywood. So that's why I drew an 8 there. Now, how far away is this going to be from the wall? How long is this ramp going to be? I'm going to use the Pythagorean theorem. I know one length and I know one hypotenuse length. So 2 squared plus b squared, b is the unknown side length, equals the 8 squared. And then I just kind of solve from there. I square all the numbers, move the 4 to the other side, subtract 4 from both sides, take the square root. I'm not going to leave it as square root of 60 because I have no idea how long that is off the top of my head. If somebody said, go build me a skateboard ramp that's the square root of 60 feet away from the wall, I'd be like, I have no idea how far away that is. So I will calculate the actual length of that as 7.75. Again, I just used Desmos. So my skateboard ramp, the length of it away from the wall is going to be 7.75 feet away from the wall. Okay, then there's a couple questions in the homework section for you to work on.